Oops. Hello, everyone. So today it's a bit experimental. Again, as you know, as everything in when we are doing in work with OBO Academy, it's all work in progress, bit preliminary, but I hope that you can get at least something out of it. So Nicole and I were thinking about this for a very, very long time to do a unit on thinking a little bit about our role as open science engineers, as contributors to open science, that in the way of collection or standardization of publicly available scientific knowledge in all our different roles, like as curators, as people that are responsible for building communities, organizing events, and data ontology and software engineering activities. So we wanted for a long time to just try and kind of phrase this in a bit more unified message of how do we think we can improve our role as open science engineer. And we cheesily called this here with a subtitle of for maximizing impact for a better world. Obviously, this is all a bit like cheesy and a bit, but yeah, we, as you know us, Nicole and I, we are sometimes a little bit cheesy, so we liked to phrase it this way. So this is obviously a complex issue. There are many different ways you can attack the question of how could you improve your role as an open science engineer. We chose the following, and maybe there are another 30 different ways of trying to phrase it, but our kind of way of putting it is like this. So open science, and in particular the subdivisions that we are mostly involved in, like open data, so the area of our environment that is responsible for trying to make data publicly available so that other people can use it, and the area of open ontology. So this is not just the open biomedical and biological ontologies foundry, so the OBO work, but any kind of open ontology work that we are involved in. These are all kind of areas that are central in our view for tackling lots of global challenges, in particular challenges that require a lot of coordination across boundaries. So for example, for rare disease, it's a very easy to understand example, because for every single patient, we have as the name says, they appear so rarely. It is absolutely critical that lots of different data sources from different countries and different grant schemes and different projects have to be integrated in order to be able to make any sense of this kind of information. And with problems like climate change, it's even more in an even greater magnitude. These are really global challenges that require a lot of interlinking and interoperability across a global environment. And here, these for these open data and open ontologies are essential components, and the work of the open semantic engineer is going to be hugely important for helping to make sense of this. You all know one of the kind of already hard problems is to even make people get people to use open licenses, but this is only just to being able to access the data, but this is only just a small piece of this. So most of you here are involved in the really hard parts, like, for example, the standardization of the data, where we are looking into unification of ontologies. So you all know the problem by now of ontology proliferation. So there are at least, let's say, 60 ontologies that you could use to label your disease data with, or you could, and there are so many different vocabularies out there. So the kind of goal of unifying something and making sure that we can jump between the different controlled vocabularies and things like that, but also verification and which I'm not going to explain now again, but for some of you, more interestingly, the definition of common semantic data models that are also publicly available and help us to understand like the data that another source has produced. Like many of you are involved in LinkML, for example, which has exactly this goal, building semantic data models that are declarative, but allow us to understand sources in a way that allow us, for example, to map them easier to each other and understand, okay, how does the data represented in this data source relate to this in this data source? So all of these different issues are part of the work of the data of the open semantics engineer. But also, and this is kind of like what we will be focusing today on, this organization of a global and fully decentralized community of open science engineers. So everyone here is, and all of you that I know and talk to every day, you're all open science engineers because you are all contributing to one way or another, open software, open data, open ontologies. Building processes that allow such a diverse group of people, financed by different grants, financed by different organizations and countries and so on, and getting them all to work together across grant boundaries, across project boundaries is a really, really hard problem. That is really much more difficult than organizing, let's say, the community inside of an organization, which is already super difficult, as people in the Monarch Initiative can attest to. But organizing across boundaries is really tough. And so Nicole and I will try to help you to with some kind of thoughts to help getting more effective at organizing as a decentralized community. We propose to divide this task into 3 different principles. There could be another 60 other principles, but these are the 3 principles that we kind of liked to use for this conversation here. So principle of collaboration. So here, this is about how do we manage these social workflows? How do we interact with each other? How do we optimize in an environment where we don't have the freedom to go for beers after work? We cannot bond over someone going for an evening to visit a colleague at home and so on. We only have our work life, let's say. And how can we still optimize a social, close-knit network that is welcoming and productive and helps each other? Then the principle of upstream fixing. Here we will talk about the idea of trying to trace errors as far to the root source of the problem as possible. And explain a little bit why, and also the principle of no ownership, a bit of a contentious idea that is borders on communism, but tries to kind of phrase the idea of having common responsibilities for community-driven resources and transcending a bit this idea of like, this ontology is mine and I'm deciding what to do with it and stuff like that, into a more network collaborative effort that with many different people coming in and out of the process, depending on the flow of money and flow of projects. All right, let's start. Okay, for those that are not so interested, you can always just go to TLDR and look at the 3 bullet points in the end that summarize everything. Too long didn't read, but we are going to go through the different principles now, roughly 10 minutes per principle. All right, I'll do a start. Nicole, you just interrupt me and chip in whenever you want to chip in. Also, everyone else, for one thing that we are interested in always is listening to your examples, because obviously we're not telling you something new, hopefully 1 or 2 new things, but I know many of you already are aware of like 60% of the things we are telling you now, and you might have even some interesting stories you would want to share about these issues, and just interrupt and come in.
Does everyone know about Stack Overflow? That's more like that's more geared towards programmers. So maybe everyone here hasn't used it before. Is anyone unfamiliar with Stack Overflow and want to know more about it? It's just like an online platform where you can post your questions and ask for help.
So I'm just going to show you a little bit. So basically, the first thing, so to jump right into the Stack Overflow situation, this is not just reduce the Stack Overflow, but the first very important thing is, and it's a very simple thing, and it makes the world a much better place, and every one of you can do it and should do it at all times as much as possible, is if you find answers to questions that you have online, on issue trackers, on Stack Overflow. So for example, here, Stack Overflow is basically this massive website, which is the primary source of information for most software engineers, at least pre-GitHub Copilot, but it's still probably the most important source as it stands right now. You can see it's like a huge system for asking questions. Everyone can ask any question they want. Like you can just go on the site. You have a problem with Prodigy, you have a problem with our API, you have a problem with anything that is, and mostly related to, let's say, more programming related issues. But as you can see here, there are lots of Prodigy related questions as well in here. And the key, and that's the only reason why I'm showing you this now, is the key is that you have these buttons here, these like these up and down arrows, and this is and what you want to do is when you're reading answers and you are kind of like saying, this is good, this is a great answer for something, you should always just reflexively mark these answers as useful. This is called upvoting. So you click on this button. I'm not going to click on this button because I haven't checked whether this answer is correct. Maybe it's wrong, so I'm not going to click on it. But you should all make an account on Stack Overflow, be logged into Stack Overflow at all times, and the same with GitHub. Always be logged into your GitHub. And when you see things like a good answer on Stack Overflow or a good answer on GitHub, so someone makes a comment, then you just go, so in GitHub, you can't upvote, but you can just, put a like or some other kind of symbol on it. This way, another person that will come to this site will be able to find the information they seek. So why is this super important? It is super important because one of the huge problems of us is that we deal with a hugely complicated network of information, and we need to be able to make sense of lots of different problems all the time, but we cannot go and ask for every single thing some poor soul, some supervisor, some person in our organization to explain them to us. So we really rely on public information to give us the correct answers. And here, this is why it is so important for us to help separating the good answers from the bad answers when we are out there learning new information. Okay, so that is.
I have a question about Stack Overflow specifically. Like being someone who doesn't really know how to code, have you sometimes, honestly, I've gone to Stack Overflow and been like, how do I do this command? And then I find something and then I get kind of nervous because I have no idea what it means or what it does. Like, am I going to run this command and it's going to be like introducing a bug or a virus into my computer or just wreck my computer or something? Have you ever seen anything malicious on Stack Overflow before? Or do you think that generally we should just trust the advice? I mean, I know the upvoted votes are probably more trustworthy than something that no one's, commented on or something, but.
So the good thing with Stack Overflow is that you can downvote stuff as well. So I would personally never, this is also a lesson that Damien, I don't know whether he's here today, but he's also constantly hammering this. Even when we are building ODK stuff, you should never execute scripts from a different site. So if a Stack Overflow answer would say, please execute the script in order to lint all your documentation pages, you should always say that you shouldn't do it unless there's so many upvotes on it that you can be sure that there are at least 100 people who have done it and deemed it safe. But generally, I would say do not run scripts from the web ever, under no circumstances. And that is the main
risk. That's exactly my question. Yeah.
Never run scripts from the web ever. And Stack Overflow is mostly not about it will rarely recommend you to do that. It's very wrong if it does.
Good to know. There's a typo here. If someone wants to fix it, there should be a parentheses on the other side of Hacker News. And somebody was talking about that on Slack the other day, right? I can't remember who it was, but just like even this week or something, someone was saying that Hacker News has lots of good tidbits in there and stuff. It's good advice and good stories and stuff.
Yeah.
Maybe that's something we all should be looking at.
Yeah, that's right. Okay, so aligned with this, now I need to move a bit quicker, but I think that this is all, I set the scene a bit that you would see many of the following points will be mirrored by this. If you couldn't find an answer for your problem, this is not like, you know, you have to do this, but consider, if it's a useful question, consider to asking it on Stack Overflow and answering it at the same time, because odds are that some other person will benefit from your quest of figuring out how to do this in the end. And this is some piece of responsibility. This also ties into this idea of improving our documentation across OBO and Monarch and all the other organizations that we are involved in. The more stuff is out there, the less time this network of open scientists needs to spend to figure out the same issues over and over again. So that is why we need to get this stuff out there. Okay, another issue is about getting involved on other people's issue trackers. So maybe, Nicole, do you want to just give an example from one of your experiences? I mean, you are very involved on other people's issue trackers, and I think yes, just as so that you get an example, give an example of why you do it and why you think it's a good idea to do that.
Yeah. Yeah, I feel like if you have the expertise and know the answer, it's really nice just to go in. Like we all have so many projects and a lot of us get tagged in so many tickets and it's hard to keep up with them. So yeah, sometimes like for example, I don't know if Megan's on the call, but I like working with her on Oberon, and sometimes I'll just jump in and try to answer questions that sometimes I just feel really proud of myself too. Like I know the answer, like I want to share my knowledge. So yeah, I feel like it's just really helpful to go in and answer questions when you know the answer, and people appreciate it. And I don't think I've ever had any like bad feelings from anyone or any negative energy from doing it. I think it just helps move things along. And yeah, it's just please give your feedback. And even that happens to me too when people chime in and answer things. It's just really helpful. Like Jim Balhoff will comment sometimes on Mondo tickets. He's really expert on a lot of ontology things, and it's really great just to gather people's feedback and just get someone to help you move your stuff along.
Yeah, I can only second that. I have now this kind of, because I have inbox zero, I have almost unsubscribed from all GitHub projects that they are, but I've deliberately subscribed to like 4 or 5 that I find interesting and I want to influence somehow. So for example, OLS or Robot, and a few others that are related to fair semantics. And when I see people like starting to debate things that I find interesting, I'm just going straight there and share my experiences or say, okay, I wouldn't do this, I would try this, and so on. So I think this is the only way that that these like disparate silos of networks can actually start growing a bit closer together. So we are, one of our huge responsibilities is to break the silos, because grants produce silos, and these silos need, if we want any chance of like really global impact, then we need to break those silos by reaching out to other places. And there's really like no serious software project will be mad at you reaching out and answering issues on their trackers and putting new issues there. I think this is a really good habit to do. Pick random ones, go there and just answer stuff and write comments. I mean, this is really, many of you didn't dare to do this, and I know many of you don't dare to do this, but this is really basic, and you should consider getting over this fear and just trying it a bit.
Yeah, I watch a lot of repositories too. Like all the ontologies that I've ever worked on, I watch the repositories, and sometimes I just get all the notifications, especially if they're pretty low traffic. And I personally don't mind getting too many emails. So depending on how you manage your emails, but I get a lot of the GitHub notifications. So then I just keep an eye on what's going on. And if I have any way that I can help, and I have the bandwidth, and I like to jump in and offer the help if I can.
This is super cool. Yeah, thanks. All right, so some basic things. Obviously, one important thing is when you have a problem, especially if it relates to a particular tool. I'm talking about specifically Oak, LinkML. These are like the big two tools that require a lot of, like, at the moment, support. Let's say it's always critical to go and search the issue trackers and search closed issues and open issues to find answers first. So this is some basic things. Everyone knows this, but many people don't do it. Like me, I sometimes think like, oh, no one has thought of this problem that I'm just made up here, and I'm just going straight to Slack and ask it. Bad thing. Yeah, we should always go and search first, and we almost always find someone else having asked the question before.
Yeah, I used to work with Melissa a lot on ontologies, and we would be working on something, and I would say, let's just Skype Chris and ask him. And she would be like, no, we have to figure it out on our own first. It could take us a while, but it's really beneficial to learn those skills on how to figure things out on your own too.
No, I agree.
And I'm sure Chris loved hearing from us, but he's very busy.
100%. Yeah, I totally agree with this. All right. Next thing. So continuously improving open science documentation. So this is really, I've hinted at it before. You see, like Nicole made this last week. She had this nice, 2 weeks ago, about pull requests. I think wasn't this also in here somewhere. Just going to put it a bit earlier. You can, most of the documentation, especially in our area, but in many other areas as well, and even if it is in issues, is editable, especially if it is on GitHub. Always keep your finger on the edit button. You see something wrong, just click on the little edit button, either on the whatever GitHub IO page you find, or just straight from the GitHub repository. Just click on edit. Everyone can just make an edit and just propose it as a pull request. There's nothing, it's super cheap, super quick. Improving documentation is the single most important thing for scaling our community to tackle more complex problems. Because right now, like, for example, now I can see first time in like 3 years that people are actually helping with doing, for example, ODK support and helping other people set up their ODK repositories. But when I was the primary developer and the primary person that knew everything about it, I had to answer so many requests that I couldn't do any other work, basically, while servicing these requests. This is not scalable. With OBO, for example, we have started putting pages together that explain all of these different sub-processes, and all of you, every single one, should always think about, where can I put this useful piece of information in a way that someone else can just find it later on. The search here is cool. Everyone will be able to find, like, for example, today I was thinking we don't have a page that explains how to compute an explanation and share it with someone on Slack. And someone could just make quickly a page, make a screenshot. This is how you do it. Put it there, 5 minutes. It doesn't take much more time. Keep your fingers and improve open science documentation. And this is really what it needs for us to scale up, because we can, while we are doing first-hand community service and supporting people to set up their ODKs, debugging ontologies, and how to make their first pull request, and why to do things like this or not like that, we cannot work. So this is why adding better and better documentation is really critical, especially while we are trying to grow our impact.
A lot of the documentation for the ontology stuff came from Go. Like, Go was the first one that created really detailed documentation, and I used the Go documentation to create the Mondo documentation, and then a lot of the Mondo documentation got incorporated into here because I had a lot of examples and things. But when I meet with, a lot of times when Nico and I have meetings and he teaches me new things, he's always right away, they'll add this to the documentation. I have it written in like random little notes on my computer, and I'm like ready just to shut everything down and lose it and have it be completely disorganized. And he's like, no, right away, add this to the Mondo documentation. And as an outcome, we have really good Mondo documentation that's also built. And I think it's in Read the Docs and searchable. It's super easy to find stuff. since I mostly created it and then Sabrina helped organize it, but it's really intuitive for us because we created all of it. And then when Sabrina got hired over a year ago, she was telling me that the documentation in Mondo is really good, and it's been really helpful for her to be able to know all of our workflows and stuff. And it actually made training her to be a breeze because we had everything documented, and she was also a very quick learner. So I can't emphasize enough, and just like what Nico said, that the good documentation just benefits you so much in the end. And I see Sabrina's raising her hand.
Yeah, it's not to talk about what you said, but I agree. The documentation is great. I have something I want to point out is, you know, and I think a lot of people here might be very new. And so sometimes when you're very new, the questions you have seems really basic. So for example, I don't know what is wrong with my protege. I don't even know how to ask. Turns out I didn't click this one button, or, you know, like, so sometimes I think people are not afraid, but like they don't feel comfortable going on a big platform and saying, what is my problem with protege? Because all it is like, oh, you didn't turn it on or turn it off, you know, like it's something like that. So what would you recommend for, you know, newbies who have questions that are that seem super basics? Because I think this is, you know, this can really talk to this audience or whoever is listening later.
So we now just I just onboarded Vinicius, who's a new member in Monarch, like super enthusiastic guy. I don't know, probably also here. I didn't look at the list.
He's here.
And I think that exactly, so basically the way that I would recommend all onboarding processes to go for it, by onboarding, I mean literally you take someone on a specific project, whether it's Uberon or whether it's Monarch or whether it's like whatever granularity, doesn't matter. The first thing you do is you provide them with 3 relevant complete tutorials that they can work through, like from end to end. So one thing that, for example, that Sean and Bradley did a lot of like amazing work on was to define for like for ontology developers in particular these pathways. And I think that this is the right approach to try and help people to get started, rather than letting them, you know, like figure out some problems. This is to actually ask them to first complete an entire tutorial, like a pathway that will take them through all the issues from getting set up to actually doing some basic things without understanding much, but in all areas of work, then starting with the tasks. I think it precludes already a lot of the standard mistakes that you would do if you would just be thrown into the cold water. That's
I would encourage any beginners like Vinicius and Katie, you did this this training recently, and if you come across things that are missing, then please let us know or go in and add them. So there might, those of us in particular, the documentation are coming from a place where we're no longer beginners, so we may have some assumed knowledge, and if there's anything missing that we assume that you already knew and you didn't, please just add it into our documentation so the next person that comes along will get all the details that they need. I find that a lot too as a non-programmer when I look at instructions to like run different programs or code or whatever. That a lot of times there's a lot of assumes that I know how to like use my terminal, and sometimes I feel like I really don't. So, and I write documentation. I try to include every single detail, like after turning on your computer, to make sure that anyone who's completely new to this, like write the documentation, like thinking like your mom is going to use it or something like that. We make sure it's like at the very, very basic level that everyone can use it without too much of a barrier to entry.
Excellent. Yes. All right, let's move on. So next big area for this first collaboration subject is social conduct and review. Here, I think we all have a lot to learn, a lot to learn. This is probably a very incomplete list. The first thing you have to understand is being an open science engineer is a lonely affair. Like all of you will work in projects that maybe are, if you're lucky, used by someone, but all the communication you will get is bugs, feature requests, basically a lot of kind of like negative messaging. Like there is no one that will open an issue, although I think that this is wrong, but that's a different issue. There's no one that will open an issue saying, awesome resource, thank you for making it, and then closing it again or something. This won't happen. And so here, this is like one of the big things that I want to kind of instill also in our work together is that you should get a bit also sensitive to the fact that this is a lonely work, and everyone that I know loves to get some positive feedback from time to time, and we don't have the opportunity for patting each other on the back in a pub or something and saying, oh man, this is so cool, or woman, this is so cool that you did how you're managing Mondo, or how great this and that works, and how OBA is now taking off, and these kind of information happens way too rarely. So I'm going to just say it outright, if you ignore everything else, try and make an experiment with becoming an overly generous giver of likes and thank yous. So likes, you can put them on issues, on issue comments, on anything you want. Like you come across some smart comment by someone in an issue, just put a like on it. If someone makes so this ties in also with this later point here with being generous with gratitude and attribution. If someone opens an issue, give them a thank you, give them some kind of sign that their contribution, which an issue is seen. If someone opens a pull request, it's unrelated to you, you say you could go, just try it. It doesn't have, you don't need to be all 17 of you going to every Uber on pull request and saying thank you for everyone that opens a pull request. That's not necessary. But if we have a bit more this culture of appreciation and a bit more this culture for all of these pieces, of all of these efforts that are being put in, this is the fuel for motivating other open science engineers. And this is the main fuel of the open science movement, is attribution and appreciation. And that's why here, star all the repositories you find useful, be they related to OBO Foundry. I don't know whether you've done this recently. Click on all of the OBO Foundry ontologies, click through them, see which ones you like, star all of the ones that you like. These kinds of things. Do it for all the open source projects that you do. It is absolutely essential for getting for as fuel for this movement. I'm not going to be good.
I don't really understand what the stars do. Do they just compare repositories to each other and say this is the most starred repository of all time or something like that?
The stars are just based. So there are two things you can do in GitHub. One is you can follow a repository. This way you will get updated about the news, whatever they do, maybe issues, maybe releases, and so on. And you have the stars. And the stars signifies that you find this project useful. As you have a positive, this is your token of appreciation to this project. It is also an indicator for other users. If they see, let's say, a lot of stars, they get more confident that this is a mature tool that they can also use. This is very important for data science, for example. But generally, it is the way that you can show appreciation for public GitHub projects. That's all that it does, nothing else.
Yeah.
Do you want to take the reduce work for others and for by communicating clearly?
Yes. Yeah, so reduce work for others as much as possible by communicating clearly. So yeah, this is I've given examples before about writing good issues or writing good tickets on the issue tracker. So I can't emphasize enough how much this makes a big difference, especially since I mainly work on ontologies. But getting the ontology requests when people take the time to write good tickets, include a lot of detail, it just makes my workflow so much faster as an ontology curator, and adding new terms or making changes to the ontology. I know it's really easy just to go in and write a quick ticket. Sometimes I even write tickets for myself that are kind of note to self, need to do this, but then even to my future self, I go back later and I'm like, what did this mean? Like I didn't have enough details, and I don't even know what I saw myself what I was trying to convey in the ticket. So and this kind of also ties in with the documentation. Just take the time to write the details and write good documentation. And when you're creating tickets, or when you're responding to, like Nico writes here, that sloppy quick responses can be more work than not responding at all. So if people, if you don't provide enough info in your responses, then it kind of creates a back and forth asking for clarification, and then I really just can create more work than just if you just take the time to initially put down thoughtful responses. Using bullet lists to structure your response. The checklists are super helpful too. We should add I'll go back later and do this. We should add an example. Joe Flack in our group does a really good job of documenting, I don't know if he's on the call, documenting the steps he's taken to do work, and then it adds checklists for things that are still outstanding. It's really evident that he's taking the time to put very thoughtful responses, and it's just so valuable to all of us in our group to know exactly what he's doing. And what is one of the best things about having well-documented tickets and commenting and thoughtful detail is that I can avoid another meeting. So there's so many times on Mondo where the ticket is so vague and the conversation is so confusing that we end up having meetings to try to clarify them, but we all would like to reduce our meeting load. So here is a way that we can do this by communicating more clearly and thoroughly in writing. So you can see on this ticket from Joe, he writes a nice summary at the top. He writes before and after changes. This is just really excellent. And this probably took him a lot of time. He's formatted super nicely using those little hash things, those little tick things. He has potential solutions. So Nico and Joe don't, probably in this case, didn't need to go and have a meeting together. Nico could just read this, especially given that they're in time zones that are 7 hours apart. This is just so much easier to be able to just work through a ticket this way than having to wait until they have a scheduled meeting or try to ad hoc find a time and they can coordinate. And then in this example here that we see on the screen right now, Bradley created this ticket in Mondo based on a ticket, and it's really nice. It looks like he used our template, and then he adds a new term request, and then he also indicates that it's for the HCA, the Human Cell Atlas, and then links to the Human Cell Atlas ticket where the whole conversation happened. And this was super useful for me because he adds all the relevant details that I need, so I can just basically copy and paste this into Protege and address this ticket in the matter of a few minutes. And then he also clicks to the external link so that I can go to that link and look at the context and see where it's coming from. And normally something so straightforward like this, I could just add in literally a couple of minutes, but this particular term, choroidal neovascularization, to me, I was like, this sounds like it's a phenotype. And I was about to comment on that, ask if this is actually suitable for Mondo. But since he provided the context of the ticket and the HCA tracker, I read that actually this is in fact a disease. He even pointed to a Medscape article that described this as a disease, and the conversation on the HCA tracker made it very evident that they needed this as a disease entity and not as a phenotype which already existed in HPO. So this is just another great example of nice work on our collaborators' part. So thank you, Bradley, for that, if you're here.
Yeah. Many good Bradley examples also that I had prepared, but we are a bit over time. So basically, I'm just going to jump a little bit over this. I think that you got the message for gratefulness, positivity, and attribution as a very important fuel for the movement, clarity of tickets. So being mindful that you should always take enough time to write your responses, write your issues, so that the person that is super busy reading it really understands immediately what's going on. This I think we've covered well. And lastly, just for you to think, openness of communication. So we've hinted at it a bunch of times, but you should remember that talking on Zoom, talking on Slack, talking on the telephone, or meeting in a pub and talking, these are really closed ways of communicating, and any communication that you have in a context like that will have to be had again in the future. So in your work with others, promote an open communication culture and recommend basically whenever possible to use fully open. Like by fully open, we mean services that you can access without actually being registered, that you could search in Google and find the results for communication purposes. All right, let's move on to the next, because we have not enough time covering everything. So we could give a little bit of a hint. So the principle of upstream fixing. So the best way to benefit the society as an open science engineer is to try and maximizing the impact of each individual change that you're doing. So the first part of this process is to recognize that all of these tools, processes, and ontologies and software and so on that we are using are a deeply interconnected web of things that depend on each other. So we have ontologies that reuse terms and axioms from other ontologies. We have software packages that build pieces from help building knowledge graphs that ensure the quality of ontology releases, that extract new insights from existing information. We have projects that use ontologies for indexing data and making it discoverable, and there's a lot of interconnected pieces here. And the key to maximizing any kind of impact is to go and try and fix an issue as far upstream, so up the dependency chain as possible. So let's look at this example. So this is a completely fabricated example, and I'm just going to say it very clearly here. This should not happen in reality if there is enough quality control issues out there. And this is definitely not saying that this exact issue happened. So we picked this example as a matter of illustration, just so that you get a bit of a sense. All right, let's look at this example here. So you have Open Targets, which is a platform for integrating information for the purpose of discovering new drug targets, providing information like this. So you can see here evidence for some gene, I guess, or protein, whatever, in a particular disease. This association is supported, as you can see here in this page, is supported only by the IMPC data source. You could trace it now exactly how, which in turn uses like an algorithmic framework called Phenodyne that is based on semantic similarity to make these kinds of connections. Which is based on the cross-species links provided by the Monarch Initiative, which are in turn provided by computations over the phenotype, the phenotype ontology, which in turn are whose links and cross-species axioms are in turn generated by a mix of logical pattern-based approaches and lexical matching approaches. All right. So this is one simple thing of how things are connected together. So it's possible then, in principle, again, not in reality, in principle, that a faulty synonym entering HPO, so for example, you add accidentally a wrong synonym to one class and you wanted to actually add it to another, causes a faulty logical axiom in UPheno, causes a faulty cross-species link provided by Monarch that is and semantic similarity result that is then used by IMPC and then leads to a faulty recommendation in Open Target. So this kind of chain is a bit constructed now for the purpose of this tutorial, but it is something that is in reality quite possible. All right, so what basically happens in this is a small thing that, like a synonym, a tiny thing that you can change somewhere in the chain that has quite a big effect on certain downstream tooling. All right, so what happens here now that when someone witnesses a problem in Open Targets, they could go and say, Open Targets, you're making a wrong, you're supporting wrong information here. What could Open Targets do? Open Targets could say, okay, no problem, I will blacklist this information or remove this information and just not show it anymore. Problem solved. But then this entire network of interdependent projects, which are much more than these like tiny subset of interlinks that we show here, then no one will actually have any effect from this fix, because this fix ends in the open target repository. They could report it to IMPC. IMPC could again decide, I could remove this record or correct the internal state of the database somehow, and again remove this information. And or they can decide to move the information up to Monarch Initiative. And Monarch Initiative now has an overview over the whole field, could relatively quickly trace that this comes from the human phenotype ontology, this problem. It would be, and now the thing is, it could, so if this information trickles all the way up there and you fix this, then you're not fixing open targets. You're fixing absolutely everything that hangs off the human phenotype ontology that is somehow reliant on its synonyms. For example, any search interface for using HPO for anything will have shown previously some wrong results based on this wrong synonym, and now all of them will be miraculously solved. So this is the principle of upstream fixing. You're maximizing the impact of your changes by tracing where it comes from all the way to the top. And this is easier to communicate in ontologies than it is with software, but in software, it is the same thing. In software, we tend to think, oh my God, it's particular. Like now we have this problem that Sierra and I and some others are fighting with the prefix maps. It's like a hugely problematic issue. And now no one knows exactly like how far up the chain do we have to go to fix prefix maps, for example, for our sources. And all the software developers that I know, usually what they do is they find a problem and then write some if-else in their code in order to circumvent the problem from the upstream library rather than going up the chain. Do not do that. Try as often as possible to find a way to coordinate with the rest of the community. Even though this is hard, it is always difficult to work with other human beings. Humans are intrinsically annoying most of the time. It's really, really difficult to coordinate such things, but it is always worth it in terms of impact to at least try it. Make an issue, see whether you can get some kind of way to fix stuff upstream. That is the principle of the second big principle that we want to get across here. And I just wanted to, give like one. I this is one story that that I think Sean supported quite a lot here with Vasilis, who came, reported. Never heard of him before, so he came to Uberon and reported that there are some wrong synonyms in Uberon, and we told him, okay, that's great. Do you feel like you're comfortable of solving this problem yourself and making a pull request? And then Anita and Sean helped, and some other people, I don't even remember, like multiple people helped them. Okay, this is how you understand this. This guy has never used Sparkle before. This guy doesn't know about ontologies, but they helped him to deal with this problem by himself and fixing these issues. And he ended up making like 8 pull requests, and on top of that, actually specifying a QC check for the problem that he has discovered, which was case insensitive synonyms, and added that as well. So this kind of like idea from him, like from his perspective, he was working on an NLP project somewhere in a company in Greece. I've learned later he was one of almost near my neighborhood in Athens. He was anyways, he was working very far away, but he could have just said, I don't care about this broken synonym, I'm just gonna fix it myself. Tuck, tuck, 5 seconds, put it on a remove list, and I'm done with this problem. Instead, he went through this massive progress of learning Sparkle, learning OBO ontologies, making pull requests, learning our standards of making pull requests, and making the pull requests. And for that, other sources down the road, that many other sources that have nothing to do with Vasilis, have now fixed some of their synonym contents and can provide better search results, and so on and so on. So this system, like this responsibility of doing this little bit of extra effort to fixing not just the problem that you have, but the general actual source problem, is one of the key issues that drive our community forward. I'm not looking at the chat, so if anyone wants to say something, they have to unfortunately just interrupt. All right. That is the story for upstream fixing. So Nicole, you have also some cool examples. So maybe you go through those a bit.
Yeah, that's a great story with the guy who reported to Uber on. Yeah, so in Mondo, we integrate a lot of different sources into this unified ontology. So I try to make an effort to try to report issues to our external sources that we're using in Mondo. So for example, we have mappings from external sources to Mondo terms, and we give them semantic definitions if they're exact matches, or if they're related, or something else. And Orphanet actually does a lot of mappings to external, or Orphanet does mappings to some external sources like OMIM. And in this case, here's an example where I just reported to OMIM or to Orphanet that I thought their mapping to OMIM was incorrect. And I changed it in Mondo and then just let them know on their tracker in case they wanted to change the mapping themselves as well. Keeping mappings up to date is super hard if anyone's tried to do that. So it's really helpful to, we get a lot of feedback from our external users about mappings that have changed and we need to revise in Mondo. So I try to pay it forward and send our changes back to the sources that are also doing mappings. And then the next example, this is just an example where Mondo and HPO are, the same teams work on these two ontologies. So we try to tag each other on relevant issues to let each other know if something, like in this case, Julie requested a synonym to a term in HPO, and then I saw, and this is a ticket I think that wasn't even assigned to me, or I guess it was assigned to me, but so then I saw this ticket and then noted that this looked like it should be a synonym for a disease term in Mondo and not actually an HPO. So then we just moved this ticket over to Mondo and address the changes in Mondo instead of in HPO. And then the next example is another one of our external ontologies, our source ontologies that we use is the NCIT, the National Cancer Institute thesaurus, and these are the experts in cancer classification. So we pretty strictly follow their expert classifications of neoplasms and cancers. But there was a case that came up from Val Wood at EBI, and sorry, she may not be at EBI, but she's part of one of the mods, and I think she's at Cambridge, and she provided a lot of evidence that the classification of this certain type of neoplasm should be a heterogeneiform mole should be classified as a type of neoplasm, which was different than what NCIT had. And we had to do kind of a bit of research and confirm that this is actually the case. So I went back to NCIT and reported to them that this is what we did in Mondo, and if they want to revisit their classification and their cancer hierarchy and follow what we did. And then our ticket has all the conversation and discussion. So we have all the evidence and links to external papers and such. So yeah, so I linked to our ticket that has a big long conversation, and then just gave them a brief summary of what I suggested that they do. So yeah, that's our examples of the upstream fixing. So super beneficial to get this kind of feedback. Definitely encourage you to take the time to do the upstream fixes versus just the kind of patch repairs that in the end will just kind of won't really benefit in the long run.
So it's really important to understand that upstream fixing does not directly benefit you if you are the only person who does it. That's why many people don't do it, because it's extra work to do this. But if we all do a little bit of upstream fixing, then we all benefit a lot from the network effect. That is why the culture of upstream fixing is really what we need to establish in open science engineering in general. And it's generally also completely underestimated how huge of an impact you can have with tiny things like fixing a command in a wrong command in a documentation page, changing a synonym from exact to related, adding a mapping that wasn't previously there, fixing a typo in a label. All of these things, they look tiny, but they have massive down ripple effects because of hundreds of different projects being dependent of direct or indirect on this information. So just know, all of you, especially the ontology curators, you're like, every single thing you do has massive ripple effects that you never really hear about. downstream. Only I hear about them because I also have to deal with the software people as well down the road. But there's a lot of impact for all of these small changes. Okay, we don't have time to really discuss the principle of no ownership in great detail. The idea, just as a summary, is that we should try as a community. We are still a decade away from this to do it properly, but we should try as a community to move away from this idea of this ontology is mine, or this ontology is monarchs, or this ontology is this and that ontology. So with Uberon, for example, we have seen how amazing, like, you have certain, there's a little bit of grant money from one grant that creates Uberon. Then there's no money, Uberon sleeps. Then a new project comes, new money comes from brain data standards, from whatever other project. Suddenly some money comes. No one owns Uberon. Everyone kind of owns Uberon, but it's better to understand that no one really does. And I think that one thought, and that's the really key thought from this section I want to just instill, is the idea of, if you're truly like a religious open science engineer, which you see, especially Nicole and me, we are a bit religious about this, then you should understand that in any case, we own none of that, because the society has paid for it. So the taxpayer is will have given the money that will enable us to do this work. So any kind of thought like this ontology is mine, or this ontology and I don't want anyone to add this or that or something like that, is flawed from the outgo, because the money ultimately comes from the society itself. So it's a good idea to try and get this feeling in, and from this feeling derive a sense of responsibility, of personal responsibility. So many of you still have this problem, and like you're doing this for like quite some time, some of you still have this problem that you believe that ontologies are owned by like mysterious people like Chris Mungall, and they need to be sort of, everything need to be decided by Chris Mungall. And this is not the right way to put it. Chris Mungall has certain level of expertise for which he needs to be tapped in certain cases where the logic is concerned, or the general framework. But Chris Mungall does not own anything. You own. And what this means is that you should be the person that is responsible for every single edit you put into any project, whether it is ODK, whether it is Uberon, whether it is any ontology out there, it doesn't matter. You go and see these changes through from the start to the finish. There's no one else that will do this for you. You will go make the pull request. You will fight for someone to review your pull request until this review is in, and you ask 50,000 times until someone does it. And you really nudge, like, don't worry about annoying people. It does not matter. Annoy them until your pull request gets either rejected or merged. So we have a big section here on avoiding to be afraid of doing this. I recommend to you to read through this, reduce your fear of breaking the ontology. This goes obviously for software projects as well. We can't cover this now, but it's really important that you get a sense of responsibility. Let's say Awa, who just started, right now you own OBA, you own Ufino. It's your thing. So you go there and just be confident and propose things and propose changes, and don't worry about it. The community will tell you this is right, this is wrong, and then the correct solution will be negotiated as an outcome.
Yeah, I always have this fear of breaking the ontology. And even when I was training with Sean and with Ray, they'll tell me it's okay. Like, you're not going to break anything.
There's so many layers
exactly.
of control that, that's like impossible to irreversibly ruin anything. And I put in this picture of screenshot of this is something that I just did like the other day, and it failed like 6 times before it passed. And then if you go on this link, you can see it starts failing again and it passes again. So this is why we have all these QC checks. And sometimes I feel like I've made every mistake that's possible to be made, and even new ones that no one knew but that could be done. So and then something new happens, and I'm like, oh, I've never done that before. So there's so much room for error, and that's why we have these QC checks, and that's why we have this community to check and balance each other. So you are going to make mistakes.
Make mistakes. Go and break things. No problem.
It's meant to be broken because we can fix it.
thank you all for your time. Time's up. And yeah, hopefully you got at least one useful thing out of the whole debate. We're very passionate, and thank you for listening and taking the time.
Thanks,
See you
everyone.
later.